afternoon, or evening, wherever you are. We're here today to listen to a talk by John Looney. This is a part of a mini conference called Cupán organized by Coding Grace. Coding Grace is a not-for-profit for diversity in tech, and I let John introduce himself and proceed with the talk. Lovely
Thank you
to
very
have you
much.
here.
Thank you very much, Andrea.
Cheers.
Okay, so yeah, I've been an old-time SRE bouncing around many different large-scale distributed systems companies over the last 20 years. And I actually wrote this talk a few years ago while working in a big company that was very good at re-implementing things. It made me think a lot about how we build replacement systems in our industry in general. And TLDR, we're not very good at it. I first learned about second system effect from Fred Brooks' amazing book, The Mythical Man Month. If you've never read it, you should check it out. It's a very important book in the field of computer science. You know, it's got all the important things like what a chief programmer team looks like and why your team needs not just one, but two secretaries. Some content, I will admit, may be out of date, but his opinion on second systems is not. So these second systems are usually proposed by people with an insufficient understanding of the existing system and the problems faced. And this is especially serious if you're in an operationally focused role, like SRE, where we can end up building a new system while running the old one and maintaining changes in both the old and the new system at the same time. And of course, projects to replace a system, they never go as well as we can expect. About 90% of all second system replacements go either over budget or are cancelled outright. So if we really knew what would be involved, why don't we refactor the old system and make it just good enough to do what the business needs? Not fantastically good, but just good enough to get the job done. Oh, so many reasons, right, that I've heard over the years. One of the most common ones is that teams just don't value good design, right? Teams would rather build 5 week-long prototypes, one after the other, rather than spending 3 careful weeks on design and then build something great in a week. Because design can be hard, right? It can feel boring. The outcome is conversations, meetings, documentation, no code. Managers can struggle to value good design over lines of code. They can struggle to reward engineers who do great designs rather than those who code poor designs quickly. Also, let's face it, software engineers are not natural thinkers, right? They're natural they're natural designers in the same way beavers are natural architects, right? They're doers, they're not thinkers. They have a job to do, they get it done, and they don't care about the environmental changes they might impact for all those around them. Now, I'm not expecting people to predict the future like some sort of amazing Sith Lord. If you hear people saying, oh, no, it's completely impossible to collect all of the requirements until we have a prototype in front of our end users, you need to take the keyboard away from them. They are dangerous people to be working with. No one wants every requirement, every little piece of the puzzle to be described in advance. Right? But using the difficulty of making a design perfect, using that as an excuse not to even try and make the design good is unacceptable. The other one, of course, is TechJet, right? It's cheap until your company stops doubling in size every few years, because you can pay off tech debt when your team is twice as large next year or the year after or the year after. Or what if tech debt causes your team to implode, right? Layoffs wipe out institutional knowledge about why corners were cut 2 years ago, why some corners are safe, and why some needed to be shored up later on. Many software engineers are used to successful organizations being growth organizations, right? That mindset applied in all situations can easily build enough tech debt to sink a company. You have to be really, really careful. Don't allow tech debt into these kind of designs, or taking shortcuts during a design phase, saying that we'll pay it off later on, can cost you way more than you expect. Now, there's also the people who don't have high opinions of the people who built the system that they're now running. And they'll come up with, oh, no, we'll do a far better job than anyone else could possibly do. Ah, my sweet summer child, I usually say. The only difference between the last team and the new team is the unbounded or unfounded optimism. There was a great story, you have to look it up, told by Lou Montulli of Netscape. This must be 20 years ago. after they spent about 3 years rewriting Netscape 4 into Netscape 5. And there was lots and lots of bits and pieces. They thought, oh, the old code base is just, it's hamstringing us, blah, blah, blah. It's causing problems. We can't iterate fast enough. They spent 3 years. They didn't add any new features. And this is at the time when the internet was young, or well, not the internet, but the web was young, and people needed to move fast. Lou specifically talks about the FTP client code, right? The FTP protocol, it's not complex. We've known about it for the last 40 years. And to download a file in Netscape 4, it took about 5,000 lines of code. So some engineer came and looked at this and went, this is horrendous. We need to rewrite all of this. And did in 100 lines of code. And then learned that there's about 200 different FTP servers out there. And all of them have weird bugs, and all of them are not quite compliant with the spec. So it took another year of tuning to get it right. And after that, the FTP client code is back to 5,000 lines of code. A full year of someone's life realistically wasted. So yeah, it took 3 years to from Netscape 5 to Netscape 6. And it didn't really have any new features. The end users weren't that impressed that the code base was rewritten. Maybe there was some small implementation improvements. Maybe there was some small performance improvements, but not enough to justify 3 full years, right? Your users, they don't care that you rewrote everything else, right? That's not a feature. So what else do we hear about? Yeah, you know, like, oh, we'll the next time we'll build it, design it to be tested. And it's like, oh, cool. Okay, yeah. Now, what fundamental thing did you not understand about the code base this time? Because let's face it, no one is perfect. You think you're going to re-implement something and it's going to be beautiful. It's going to have all of the latest, greatest frameworks in it, or maybe it's going to use new best practices that you haven't heard of. But no. If you're not competent enough to retrofit testing into an older system, I don't trust that you're going to build a new system that's going to be beautifully tested. What else do we hear about? Ah, yes, the language nerds. Changing language is absolutely a misfeature. It's not like if you advertise, oh yes, our new stuff is all written in Rust. End users, again, don't care, right? Changing language, it's a misfeature. If you need to skill up your existing people and build a whole new tool chain, all you're going to do is make things slower. It's not a benefit unless your company, your organization, your team has decided it's going to invest properly in this new language, right? They need to be okay that the first few projects implemented in this new tool chain are going to have a higher chance of failure with respect to budget, schedule, or quality, right? You're going to have to retrain people. Do not go into this, you know, assuming that everything's going to be better because you've dumped the language that you have learned to hate over the last few years. Now, I hate this. As a manager, I really hate it. It works more often than I'd like to admit. Yeah, people get promoted for new things. They don't tend to get promoted for maintenance. And this is a call out for managers. Please don't reward new things just because they're new, right? Ask what would have happened had time been put into the existing system. Don't promote people unless people can show their homework. Show that, yeah, this new system was definitely justifiable with hard data, maybe even that you did a bunch of spikes to retrofit things into the old system. Because, yeah, like managers being lazy and saying, I'm going to promote people based on implementing new things, you're just going to get hundreds, thousands of new little projects that are small and built just to get people promoted. And that's not a way to build a successful company long term. So, I reckon it takes massive hubris to assert that you can implement a new system, all of the critical functionality of the old system, enough cool new features to justify calling it version 2 of a new system, and implement all the new urgent feature requests and maintenance problems that the old system is going to throw up. And of course, we're going to have to add to the new system as you're trying to build a replacement, because you can't take 2 years and say, we're just going to park the old system. We're not going to maintain it. We're not going to extend it. We're not going to really support it while we're building the new one. That's just not a thing. So if you've got 4 people looking after the old system, you need to hire 4 people to build a new system while the other 4 are looking after the old system. There's no shortcuts. We usually call the period between heavily investing in the new system and turning off the old system the death march. Because if you don't complete it, none of your sacrifices were worthwhile. Why are you hitting yourself? Right, so a lot of the impetus for this talk came out of an interview I did with Ron Minnick a few years ago. He worked on Plan 9, which was the sequel to Unix. Ron worked in it back in the late 80s, I suppose, early 90s. At the time, Ron and I were at the time of the interview, Ron and I were collaborating on an open source firmware project, which was trying to replace UEFI, a complex project with a 2,500 page specification written by tens of thousands of professional software engineers over 2 decades. So yes, the irony of this talk is not lost on me. It's less painful, though, to talk about a second system effect in the context of something like Plan 9, something that was, from 20 or 30 years ago, rather than picking a project that I worked on and I'm still sensitive about, or maybe one that one of you had rewritten. So even I'm too young to understand all of the detail that Ron fired at me. So forgive me if some of the details are a bit incorrect, right? Like any Irish story, the important thing is afterwards, everything that you remember should be true. The rest is just color. So let's go back to the start of the time. The start of the current epoch, 1970 to be precise. Unix was initially simple OS. It was accidentally portable because they chose to write it in C. And it was certainly more portable than the previous operating systems around that were written in assembly. So a lot of time in those early days with Unix was making Unix simple. Every piece of mental energy a user or a programmer spends understanding a beautiful, complex abstraction is time they don't spend getting shit done. They're less likely to use it. They don't want to adopt it, etc. So it happened that everyone in the room building Unix in those early days deeply cared about getting design right? They weren't in a hurry. If it took 5 or 6 years to get the full OS done in the way they wanted it, that was fine. Oh wait, no, except Stephen Bourne, right? His decision to implement the Bourne shell using C macros that made it look like you were writing Algo 68 code was utterly demented. But the rest of the design of Unix was pretty cool. So, to reiterate, it's far harder to make something simple to use than to make something complex. And it's the real reason that lines of code is a terrible metric. Good engineers always do more with less. The simplicity, the portability of Unix, it's the reason that it's everywhere 50 years later. So in our conversations, Ron stressed a few times that Unix is around today because it stayed true to patterns designed for machines that only had 64 kilobytes of RAM. And that were later tweaked for systems that had 64 gigs, right? A million times more RAM, same patterns work beautifully. The original PDP-9 instruction set was also really simple. It's a very, very small number of registers, very small number of instructions. It was simple, right? It got people used to doing complex things with simple instructions as building blocks, and that was easier for others to understand and contribute to. Now, the most famous Unix abstraction was the file interface, right? This is the operating system presenting a file system, effectively a directed acyclic graph of nearly all system resources. Nearly. The operating system needed far fewer commands than previous and probably subsequent operating systems. The APIs to most of the machine was just file I/O, right? Open a file, read it, write it, close, done. So think about the last project you worked on. When designing it, how long did you spend seeking that simplest abstraction? How many alternatives did you consider? Who did you ask? Because what's simple for you may not be very simple for the other people. Who did you debate with? Like, are they good at pushing back? Or do they just accept whatever design you come up with? Or will they have really long arguments about it? Because if you've got software that's going to be there for 5 or 6 years, it's worth spending a week or two thinking about how it's going to be built and how it's going to be used. The goal is, come up with the simplest solution. Now, when Unix was designed, they spent weeks, probably months, arguing what should be a system call, what should be in libc, what should be in higher level abstraction. malloc, for instance, could have been a system call, but they chose, no, we can actually make this simpler if break is the system call that just, subdivides memory, and then malloc does all of the work on tracking where things are. That vastly simplified the kernel, which is, of course, the most expensive place to put any code and the most expensive place to do maintenance. Now, Unix, as it got successful, it attracted less dogmatic engineers, right? People who wanted to use Unix to solve specific problems rather than because they wanted a beautiful operating system. The biggest example of this is probably SGTTY, the first terminal interface. People couldn't work out how to use a file API to do all the settings they wanted, like bitrate and parity stop bits, placing characters in weird places. So they went, let's just make a new IOCTL API. It was an horrendous, ugly, temporary hack. It used a global integer. It wasn't even unique across resources, but it got serial consoles working quickly, and that was the important thing, right? People were sick of only having output to printers. Disks, tapes, paper and magnetic, were also troublesome to implement as files. And as more and more people papered over issues with IOCTL, it upset the Unix purists. For the next 50 years, it was never resolved because it worked. Here's the problem. Broken gets fixed, shitty lasts forever. Now, networking was really hard to fit into the file abstraction. The first implementations were kind of crazy. You could create a file in /dev/tcp/host/80, and that would then give you kind of a port. You could read and write from the web port. Cool. You can actually compile up a version of the bash shell with support for those file APIs. No one uses them because they're kind of weird, right? There's limitations that took a while to uncover. What happens when a file, when someone changes a DNS name and you've gone like dev, TCP, hostname, port 80 or whatever you're trying to connect to it, do you rename the file? Do you delete the file? Do you have to... early implementations, actually, they just said, how about we just delete it, close the connection, recreate the file, recreate the connection. And people are like, you're going to drop my network connections just because someone changed DNS? This sounds kind of weird. So yeah, special cases are hard. Now, Plan 9 was started about 20 years after the first Unix version shipped, and it was proposed to fix a load of these design issues. It would have a fancy new microkernel, which is the coolest stuff in the late 80s, early 90s, where the kernel only does memory management and the global namespace. It had a new 9P message protocol to talk between microservers, all brand new. The idea was a driver was anything that needed privilege to talk to a device, right? So you could implement that as a 9P server, and suddenly now device drivers were just user mode programs. People got very excited by those. RAMFS meant that RAM could be kind of technically a 9P server. You could mount multiple of them, like a C group. Container group is what we call these days. Any process can ask for their own namespaces, mount them under their own /MNT. You don't need a messy global namespace that made Unix so untidy. We could have had containers in 1993. How cool would that be? Maybe Docker would never have arisen. But this is now looking like a pretty exciting second system, right? Just like Unix, but fixing all of the problems, extending the philosophy of one component does one thing and one thing well. And it doesn't look like it's going to take long to hit those goals, because these are pretty modest goals. So why did it take some of the finest software engineers on the planet 13 years to get to a place where they go, it's time to abandon this project, it's not going anywhere? Well, as soon as you say, we're going to do a new system, right? People offer new requirements that didn't seem important enough to be implemented on the old system. Or worse yet, they'll recommend that you use new technologies, new solutions, new frameworks, with no real justification for using them other than we really want to try them, like microkernels or new languages. So both types of feedback can send a project drastically off mission. Plan 9 was intended to make a better Unix, right? It wasn't intended to be a proving ground for new tech, like true believers of microkernels wanted it to be, right? These people were not making data-driven decisions. They thought these things were cool, and they wanted to bundle it in. So now, if microkernels don't work, Plan 9 is going to fail. That's not a great place to be in as a project. A good practice when doing any kind of system replacements is to break down a monolith, right? Rewrite each part of the original system incrementally. Now, the team felt the Unix code base was 20 years old, and rewriting wasn't as valuable as starting from scratch. And there was some merit in this, right? This was not a data-less decision. The Plan 9 kernel ended up being around about 150 lines, 150,000 lines of code. System 5 was already 2 million lines of code by the mid-1990s, right? So it's almost 10 times smaller. As a data person, that's good for me. The important thing is they had data, right? They had stats on the code base. They showed what code wasn't used, what parts didn't have maintainers anymore, and that's a good sign that it doesn't matter anymore. Or here's the thing. It's okay to say we're removing this feature, a small number of people use it, but not enough. Like if 3% of people are using something and it's slowing down every test run, every build, or the onboarding of any person, you're better off saying, we're just going to cut this feature. It's not as cool as we thought it was going to be. It's a pain in the ass for everyone to look after. Now, Rob Pike, he really cared about getting System 9 perfect. Around 91, he had a chance to win a contract with Sequent Computer Systems to supply operating systems for their new top-end servers. For the young people out there, in the old days, every computer manufacturer used to ship their own operating system with their hardware. They might even ship their own networking protocol. It was kind of Wild West. So Sequent made very cool redundant servers, massive machines. In 1991, you could get one with between 1 and 20 486 chips for between $50,000 and $1 million in today's money. I used to play with a quad Pentium on my first internship. It was the fastest machine I'd ever used at the time. Very, very cool hardware. So if Sequent went with Plan 9, other people would probably copy them. Now, Sequent needed a get PID system call for Unix compatibility, so you can get your own process ID. Rob told them, just read /dev/PID on your own namespace. That's how we do it. But this would change or require changing code in existing apps. Everything that was written for Unix would have to change the get PID to read that file, open that file, read it, etc. And worse yet, the Plan 9 implementation was kind of slow. So they said, look, some apps call this hundreds of times a second. And he said, they should cache it. He refused to improve it. So if you run strace on a modern system, you can see get PID is easily the most common system call that's called. Now, winning the contract for Plan 9 meant that it had to be as fast as Unix. Winning it would have meant that Plan 9 would start to replace Unix on high-end systems, and then low-end systems would follow later on as they, got their hands on Plan 9 and they could implement it on the smaller machines. One of the Plan 9 team made a neat hack to Plan 9. They took the PID into the process stack on creation, so it could be quickly pulled out by a process anytime it wondered about its own PID. And Rob Pike said to the engineer, the way you're doing this is very elegant, but it's wrong. We should be reading from dev PID. So Plan 9 didn't use the file API, it didn't use the file API, which Rob wanted everyone to use, invented a new one. He refused the patch. So Sequent never sold servers with Plan 9, and neither did anybody else. Linus Torvalds, he's a great example of someone who is much more interested in people using his project than doing things perfectly. Now, don't get me wrong, he has a lot of opinions. He does like things done well, but he knows when to compromise. Ron told me years ago about Coreboot, a project he was working on to get open source firmware for AMD machines. Probably mid-2000s around the Opteron time. Software written by hardware engineers is often terrible. In this case, it had loads of far jumps. These are kind of go-tos written in assembly. Confusing, scary code that you can't test, you can't understand. But the project didn't have time and people to do it properly. It had to focus on getting more contributors, getting more users, and getting it working on more platforms. You can't stand in the way of enthusiasm, right? It will not come back. Successful projects know when to compromise their design principles and when to hold firm. So let's go back to Plan 9. In a mid-1990s ACM conference, someone benchmarked Plan 9's network stack and showed that it was a lot slower than BSD. The socket, listen, accept cycle on BSD and Linux is fast, maybe like 2 million connections a second. In the early 2000s, though, Plan 9 could only do 20,000 connections a second. It does loads of namespace traversals. The messaging protocol wasn't incredibly efficient. So Ken Thompson had designed this beautiful model, but it wasn't fast. By not having that speed requirement in early, like no one said, we should be able to do 1 million connections a second, it proved really hard to speed up later on. Worse yet, when challenged on this, Rob Pike asserted that performance was never important after finding out about the problem. And I find it just like fascinating that an outsider, I think an intern maybe, spent a summer on the Plan 9 networking stack and they bumped the performance by an order of magnitude from 20K connections a second to 200,000. The original team had decided because their stuff wasn't fast, therefore there wasn't a requirement to be fast. And if there wasn't a requirement to be fast, no one should spend time trying to make it fast. So they didn't go looking for optimizations, right? They just assumed it wasn't possible. They didn't realize that by justifying a design, they'd become trapped by it. There's a really cool document called the SGI IRX bloat document. It's an overview of IRX 5.1. I think I found it on Usenet around 1993, 1994. But it's iconic, right? It's a step-by-step takedown of how 12 months of improvements slowed the IRX operating system down by 30%. It's a convincing call to me for vigilance. You have to ensure performance through successive releases by being really brutal and measuring all of your changes and what the stuff is supposed to do. Speed isn't everything, okay? Though simplicity matters. The Plan 9 network stack, which, yeah, was a bit slow, was so simple that it could be ported to other operating systems in 3 months by one person. It's about 2 years to do the same thing for BSD, which is simpler than Linux. So Linux could be 3, 4, 5 years of work. That means it's really easy to build features on top of it, right? So it's a situation-dependent trade-off that you need to be aware of. The /proc file system, which is in Linux and many other operators today, was actually a Plan 9 idea, and absolutely fantastic. It exposed the hardware and process internals as a file API. You could be on an x86 machine, you could import /proc from a ARM box over the network and debug an ARM9 binary using nothing but files. So much simpler than remote GDB and all sorts of remote debuggers, things like that. These things are simple, if not fast. But other Plan 9 problems surfaced when interesting design impact the real world and real users. A great example of this is mailboxes. So they said, yes, absolutely. In Mailbox, every mailbox is a file. So you point your text editor at a mail directory, boom, there you go, you got a mail reader. Very cool. But performance sucked. Directory performance was something like n log n compared to the number of files in a directory. So as people got more email, their mail performance sucked. The designers blamed the users. You've got too much email. You should delete them. You should have separate mail folders. They didn't like that they had unreasonable expectations, performance expectations of a cool design. So, you know, people used BSD and other systems for their email, and everyone was happy. No one used Plan 9. Now, it's really interesting how simple, valuable design can be, how simple and valuable a design can be when it's recursive. Rio, the Plan 9 windowing system, imports and operates on only 3 file handles: a graphical device, a keyboard, and a mouse. So every new window created in Windows namespace recursively imports those 3 devices from its parent window. So that means Rio can kind of run itself in a window on another windowing system like Apple Quartz or Wayland. Any system written for Rio can run a window from any other application as long as it passes the 3 file handles. So you get like features like full screen or nested windows are just implemented for free. Amazing for debugging window managers or Windows applications. It's a really powerful metaphor, and they could generate a small amount of very high performance code that worked well, and implement a really cool windowing system that could have all sorts of, you know, expansions very, very quickly. But most engineers didn't try and understand it. They thought it would be very complicated. And it was telling. When Rio was implemented for Linux, the only two implementation features the two had in common were the look and the feel. They really didn't understand the abstraction's original design power. To them, it was just a UI, right, that happened to require 20 times the lines of code as the original Rio implementation of Plan 9. Because to the Plan 9 people, simplicity was in their DNA. And so when people try to copy stuff from Plan 9, it usually got more complex, less useful, less reusable. Now, ultimately, Plan 9 never replaced Unix because AT&T Legal didn't want to lose control of the project. They considered Unix a massive failure because other people made money from it. The lawyers refused any sort of open source release until well after Plan 9 was irrelevant. I remember asking Eric Schmidt about this, about what he learned from his Sonos work and Solaris when he worked in Sun Microsystems before he went into management. And he said, you either are the open source reference implementation, or you get replaced by it. I thought that was such a succinct way to wrap up how Solaris went from the coolest operating system or the coolest version of Unix to the irrelevant version of Unix. Because let's face it, we all use Linux now. We don't use Solaris or Plan 9. Linux isn't as beautiful or as simple, but it worked quickly to get a solid community. And that community then were able to fix issues they found, the ones that were important to them. It had a culture of engineering excellence, but it was tempered with occasional pragmatism, right? And they built something really great. Unix lasted 30 years before being replaced by GNU and Linux or whatever. They were arguably a ground-up re-implementation for legal and technical reasons. But honestly, the need for re-implementation of Linux seems as unlikely now as it did 10 years ago. Like, it's nearly 30 years old, 35 years old. It's old, and it's fine. They really got the balance of design purity and pragmatism right, and they have invested a lot in keeping things going. So I asked Ron for any more advice on, for people who've never built simple operating systems for those old 16-bit systems. Well, he tells everyone, check out uroot. It's a project used by Linux Boot and a few other projects. Uroot's original goal was to show people how Unix commands could be rewritten in a reasonable language, Go, and portable. It's intended as a teaching example, but it does happen to be very useful in the real world. It's grown enough, actually, to be able to replace the Plan 9 user space in many systems. When I worked in Facebook, I managed to get Linux and the uroot user space into the 5 megabytes we had free on older switches. That's pretty cool these days. Ron also said, go get practice with microcontrollers, right? They're very interesting constrained environments, and they can be good fun. And they will make you a better software engineer. He also had this nice idea that I'd never heard of before, and that was after writing a week of code, spend a few hours thinking about what you can delete. Just like when you write a really good blog post, your editor makes it much better by deleting maybe 30% of the text. Code is no different. And lastly, if you have an idea for a new project, look at the projects that already exist. Think long and hard about making them better, rather than deciding those projects are no good, we're going to re-implement everything. Yeah, because I think Ron has had his fit of new systems that take a lot of work and then go nowhere. Thank you.
Thank you.
Oh, my audience.
Yeah. You're a good fan club. That was really good. I don't know if it comes out. Okay. We should move there, right?
Yeah. Yeah, just go over there.
Not destroying anything.
Yeah. We just record Q&A, and then after that discussion, we can turn off.
Yes. Yes. Okay. Well, I don't know if I'm assuming we're live, and that was a great talk. Really interesting. So
Thank you very much.
what I love about your talk and the previous talk as a kind of coherent whole is that you mentioned a lot of history, and you also touched on culture.
Yes. Well, I am very old.
I am also very old. I know I look great, but I'm also very old. And I don't know how other people and what our audience is or whatever, but I think it does mean that as we're in software longer, the effects of thinking about things, the focus on design, right? I guess if I'm gonna kick off my first question, and I'm hoping other questions come from other places, I'm just kind of warming up, and it's like, oh, ask my question. So send it on, and we'll put it through. My first question would be like, what do you do to reward with the people that you work, to reward the behaviors that enable people to design things? Because designing software is hard. It's something that at least I learned by banging my head against walls, kicking things, and stuff. Basically, painful process of trial and error. And maybe you read some good books, but what do you do?
Okay, so often I'm trying to surround myself with people who are smarter than me and better at designing with me, right? But a few times I've worked with people where we could have done a small version or solved a smaller problem, and we took a step back and go, whoa, what if we could do a more holistic, a much better long-term plan that would, can we design something that rather than we'll use this for a year or two, we're going to get 5 or 10 years out of it? Or can we do this so that it's going to be reusable by multiple people? This can often be called, managers will call it death by framework. And that's where I have a problem to solve. First, I'm going to build a framework to do it. And so when I'm looking for a good design, I'm looking for, is there a hint of a framework that can be built later that's going to solve, 50 teams' problems? but we're going to concentrate on getting that first team's problems done first. So we're only going to build the framework that is needed for this problem today. And this is the extensible, the Lego version maybe of design, right? We're not going to paint ourselves into a corner, but we're also not going to just build, we're not also going to waste years building something before we get real use out of it. And this is really, really, really tough because the design purist, they want to build something beautiful. And I'll have to say, okay, but what's the first what's the first project that's going to use it, and when will we see the benefit from it? And when you ask that, some people get very upset. They're like, no, we're going to build this we're going to do the framework for a year, and then we're going to have something working. I go, oh no.
And it will go live, and it will just work flawlessly, right?
I don't believe you. Like, if we don't use your framework, we can do this in 4 weeks. So is there some way that you can build a little bit of your framework, and I'll give you 5 weeks, or maybe 6, but you're not getting a year.
Yeah,
And I think that's the constraint. So getting those non-verbal kind of constraints that are not usually said along the lines of, I want this extensible, but I also want it quickly.
Yeah. So basically, if I could kind of paraphrase your answer, it's something like good mentorship in the form of working with people that are smarter than you, and also kind of enabling constraints. So, in your case, you're kind of especially kind of honing in on deliver fast.
Yeah.
Maybe I'll give you some more room to wiggle to find a more generic solution, and maybe even buy in some time to think in the small, and then so that you can find the thinking at large.
Yes. And another important version of that is that we all get asked to review other people's designs from time to time. And most designs are not actually all that interesting.
Or
They're
good.
It's like, okay, cool, this is probably solving a problem that I don't have, but it seems like a valid problem. That's cool. If you keep thinking about your design until people go, actually, that's pretty cool. Okay, I didn't think of that. Then you're on the right track. And honestly, you should keep going until people get genuinely excited about a design. Again, it's not for everything, but there are places, really high leverage parts of low-level infrastructure, maybe, or reusable frameworks that design is going to be required. And if you can't get people excited about it, maybe you're not doing anything different.
That's nice. Do we have any questions from? Okay, you need to read it out.
I can jump over.
Yeah,
Hello.
Thank you very much.
Are you in the picture? Did you
I
just
hope
go in?
I'm in the picture.
Yeah.
Gonna shuffle over.
Okay.
Loads
so-
of room in the workshop.
It's okay.
Oh, yeah. So, do you think the over-indexing of the developer as a user driven by Plan 9 set the industry back, and we're only just rediscovering it with initiatives like DX?
So, that's an interesting one. Right. The with Plan 9, the user was the developer. They didn't have any other users, right? It wasn't like Next or OS X where the end users were non-developers. With Plan 9, it was like everyone who is using this should be contributing to Plan 9 or the ecosystem in some way. All good dying projects are dead projects. I don't mind if a project fails. In fact, fail early, great. But then work out what can you give the world from the corpse of your project. And Plan 9 gave loads of things. Like there was a bunch of nice user space tweaks. Sorry?
Algo ring spells there.
Yeah. And okay, Rio didn't go anywhere, even though it was a nice design. But hey, /proc is something I literally use all the time. And this idea that you can expose more of the internals of the system via the file system API than ever before, fantastic. That, again, not exactly an end user thing. Mostly used to sysadmins and software engineers. But what else?
I mean, you can argue some of the Plan 9 DNA lives on in Go as well. I think.
Oh, absolutely, absolutely. And Go is a fantastic language for that reason. Like, it was intended as a better C. It wasn't a perfect C, it was a better C. And I think there's a big difference there because they wanted people to be able to write code very quickly as well as reasonably safely. Yeah.
Well, I have a okay. This is a bit of a weird question. How do you deal with dissenting opinions? So you're talking about design,
Oh, yeah.
and you just said something that I was like, I completely disagree with that, and it doesn't even matter what it is. But what it does matter is how discussing things is really difficult, especially in software, because your opinion of something elegant might be, I'd be like, well, I think is trash.
Yes. Okay, so I've been managed many software engineers over the years. I think, like company culture, design ethos or design patterns are. It's really important for everyone to agree on them because you can go faster when everyone agrees. Okay, there's problems at groupthink.
Yeah.
Often that's more important than really hashing it out. So often, if you're in a group and there's 7 or 8 people on the team, and you find yourself often disagreeing with the majority, you're in the wrong team. Like, and it's
Yes.
better for you to move to a team that more agrees with you.
Mm.
And I've done kind of like an intervention occasionally, where I'll have a team of 4, they're working along, we hire a new person, and they go, oh, there's all these extra features we can use in Golang, or we should be using metaprogramming in Python. And the existing team go, nope, I've seen that go wrong before, we're not doing that. And so they're now waste time having these discussions about language features, when the actual answer is, if you're on this team, you agree with the rest of the team, this is our design patterns, our best practices, stop with the advanced language features. If you want to do those, you need to find a new team.
Mm.
And so I would say the majority of people will just bite their tongue and go, okay. And then 6 months later, they go, oh, now I understand why the team designs things like they do. Because in their space, in because of the design criteria, or maybe the we're building stuff for 10 years, they then have a deeper understanding maybe of why the original team took those choices. And sometimes they'll change them, but honestly, it is better just the team has to agree. And if it doesn't naturally agree, you need to refactor the team.
Yeah, and obviously that's the pattern when you have established teams. But which is this, you are there most of the times.
Yes.
So when you're establishing it, there is the storming side of things. And
Exactly,
blah,
the whole Tuckman model. You're right. I think the team finding its feet really quickly is going to be important. And the best way to do that is have these giant screaming matches. Decide which ones you're going to agree on, which ones you don't. And then have the team go, are you willing to, Anil, to agree? Are we going to go with this? Or do we need to split up? And it can be very, very hard. Like, the number one thing that dictates a team, if it's successful or not, honestly, is the amount of time it spends together. Or has spent together.
Do we have something there?
Yes, we have more questions. I'm going to step back into frame. Oh, 2 questions, actually. First one is there any red flag that says, actually, we do need something new from scratch instead of extending the existing application, i.e., hold, do we know when to let go?
Ooh, okay, so I can only be super specific there. Like, I've seen projects where we had a monolith, it was built for policy reasons, for legal reasons, no one wanted to re-implement how we handle cookies in separate binaries, so it's all been thrown into the one place. And then you go, oh no, the way we're handling events here is terrible, we're going to have to rewrite all of that. We just, actually, specifically, requirements changed. So the old monolith, maybe it was fine to take 100 milliseconds for the 90th percentile. Life went on and someone said, no, we actually now want to be 99th percentile, 70 milliseconds. And you go, we can't guarantee that with the old eventing system. We're going to have to re-implement that whole core. That's one of the big red flags. Other ones can be if you have a large amount of dead code. So if you go through the code base and you just see a constant pattern of the last 10 years when features fell out of favor or didn't get used, the code is still there, no one deleted it. The only difference is maybe now it's not tested. So if you have these radioactive storage pools, sometimes you kind of do have to walk away. Like, if they start building up to an appreciable percentage of the code base, it's a big problem.
It's quicker just to rewrite it at that point.
Yep. Another one, one last one, I think might be the test release cycle. So as software builds and accretes or whatever, it can take longer and longer. I've definitely worked on code bases where it took a week to get a very small change in and a week to test it. And suddenly it's now taking 2 weeks to do small things and they feel hamstrung. That's another one. You need to make a good, honest try for how do we make it quicker to build and test. And if you can't work it out, or you're thinking, we spent a month at this, we haven't really made a big difference, let's just spend 6 months rewriting the whole thing. That's probably a good red flag as well for it's time to bail.
Cool. And then the second question, does John have any strategies for integrating a predecessor and successor applications during a transition period, i.e., as one goes from to the successor application?
Wait, okay, so this is called extending the death march. Rather than having a fixed cutoff where we're going to switch from the old system to the new system that has most of the features, but some things won't be implemented for a while. I'm trying to think of it's always useful for specifics. You can implement shims in the old system. A good example actually of this is you put a proxy in front of both, and you basically have that cater to any features that don't exist in the new one or need to be papered over. We can. I'm trying to think of specific examples. Like many years ago, I was moving from Google File System version 1 to Colossus, and there was just loads of features that didn't exist. So we ended up implementing kind of we had the base thing with fewer amount of features, and we said we'll add a namespace on top of that that will add extra features later. And the idea, tell our end users which functionality set do you need, the one that works and is fast, the one that doesn't work and is evolving, make that explicit. Or you can do the proxy one where everything comes into one, and you go, oh, we don't support that feature, remove it from the request and pass it on. Those kind of things can be very helpful. There's no shortcuts though.
I have to +1 the proxy. I've used that strategy quite a lot. It's also a great way to get insight into the old system.
Who's using it, how, etc. Yeah, because let's face it, the old system probably doesn't have great observability.
Usually that's the case if you don't know the spec at that point, or you don't have a good idea, that means you probably don't have good insight.
Yeah, a simple version actually. Imagine you're replacing this old monolith. I'm thinking of one we have in Reddit. There's best part of 1,500 RPC endpoints. Which ones of those are used? You absolutely need to know which ones are used and which ones you're going to turn off and break people's code, because you can't re-implement all 1,500.
Yeah, another strategy I've used is the next stage is actually have a proxy then replaying requests to a second host or second implementation.
Yes.
That can bottom out a lot of problems really fast.
I think that's a really good first strategy. I think that's a really good kind of first part of the strategy, to do both. Like, you do the real one, does the real thing, and then the second one just plays it, and initially it all breaks, right? And you're like, oh, okay, all of these things are severely broken and it won't do. But you kind of now have all the observability, this is actual real live production patterns going through.
And let's face it, the old system may have accidentally been performant for some truly bizarre stuff that the new one doesn't. A great example of this might be, imagine you say, oh yeah, we're building this web form, whatever, and we're going to have an RPC to pull in comments from a user. And so give a user, tell me their comments. And you're building the new system and everything's cool. You forgot that there's one user that has 18 million comments because it was a bot. And then suddenly the old system would just cap it and say you only get the top 100 comments, and then you go. While the new system tries to get everything, and it'll when it comes across that request. So yeah, being able to replay traffic is against the new and the old system is
Very nice.
very helpful.
Cool.
Do you have anything else? No.
Everyone's very quiet.
Well, then we can close it and stop recording and stay there.
Okay, well, that
Very
was
cool.
great. Thank you very much. That was very insightful. I'm just going to shuffle over here and stop the stream.
Hey.
Hold on. That was
Need a cup of tea, 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 need a tea, need a cup of 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 tea,